A piece of data is made of two parts, data name and data value. The name works as an identifier. We use it to access the value it represents. Variable name, property name, function, and method name are all value names. To remove a piece of data from the memory completely, we need to remove both the data name and value. To remove a data name, we need to remove its scope. The global scope will stay alive in the memory until the end of the program execution. It cannot be removed ahead of time. Otherwise, the program execution cannot go on. As a result, global variables will stay alive in the memory until the end of the program execution. But if we define a variable inside a function, then that variable will be a local variable. Once the function has been invoked, its function scope will be deleted, and as a result, variables defined in it will be removed from the memory as well. This is why, if possible, you should always choose local variables over the global ones. They won't occupy the memory space until the end of the program execution. The memory use can be more efficient. A scope is entry-only. Its own data cannot be accessed from the outside. Such a design makes sure that removing a scope won't affect other scopes. Data values are removed by the garbage collector automatically. Before 2012, JavaScript used reference count to decide whether a data value should be regarded as garbage or not. Reference count is the number of names a value is associated with. The reference count of a primitive value can either be 1 or 0. For example, we assign a string to variable message. Now its reference count is 1. If we reset the value of the message variable, then the reference count of the string will drop to 0, which means it will be removed by the garbage collector. Next, we create an object and assign it to variable A. An object is a reference type value. Its reference count can be bigger than 1. We assign A to another variable, B. Now the reference count of this object is 2. If we reset A's value, the object will continue to stay alive in the memory because its reference count is 1, not 0. To delete the object, we need to reset B as well. Now the reference count of the object has dropped to 0. The garbage collector will remove it. If we no longer need the object but forgot to reset both variables, then this unneeded object will continue to stay alive in the memory and occupy the memory space. This is called memory leak. The limited memory space is wasted by a piece of unneeded data. As a result, the available memory space for the future program execution is now smaller than it should have been.